Hello students. In today's class, we will discuss that how we can identify the types of protons in a molecule at first sight. What things we must keep in mind while looking at a molecule in case of proton NMR. For example, here is a molecule of ethyl propanoate. Now, first identify how many types of protons are there in a molecule. Number 1, A, this CH2's proton, B, this methyl's proton, C, this CH2's proton. Both CH2s are not same. They are present in a different environment. This CH2 is close to the oxygen, which is really electronegative atom. This CH2 is attached to an sp2 hybridized carbonyl atom. And number D is the methyl group. Again, these two methyls are not same. Okay, because this methyl is attached to a CH2 which is directly attached to an oxygen atom, and this methyl is attached to a CH2 which is attached to an sp2 hybridized carbon. Clear? Now, there are 4 types of protons. Second point is this: which proton is downfield and which proton is upfield in a proton NMR spectrum. Number A, this CH2's proton will give a quadrate signal. Why? Because it is adjacent to a carbon atom which has 3 protons. 3 plus 1 equals to 4. One signal is of itself and 3 of them is of methyl protons. So it will give a quadrate signal. And it is downfield. Why? Because it is attached to an sp2 hybridized carbon atom. So it is downfield. And its value will be around the greater than 22. Oh, sorry, greater than 2. Okay. B. This methyl will show a triplet because it is adjacent to CH2, means 2 protons plus 1, 3. 1 proton is of itself and 2 of them is of CH2. So it's upfield obviously as compared to CH2. And its value will be around 0 to 1, very low. Now coming to the C proton, CH2C. It will give a quadrate again because this CH2 is beyond adjacent to CH3. 3 plus 1, 4, quadrate, and it is really downfield because it is adjacent to OCO group. It is very downfield as compared to this A proton. Why? Because A is adjacent to the sp2 hybridized carbon atom, but this C proton is beyond the very electronegative oxygen atom. So it is more downfield as compared to the A. Number D. It will also give a triplet, the same reason which I have said already in case of proton number B. So the signal will be like this: 0, 1, 2, 3, 4, 5, 6. It's a tentative spectra, okay? And CH2 quadrate C will be there, the most downfield, and between 2 and 3 a quadrate, second quadrate, CH2 again, A, then 3 a triplet, CH3, D, and again CH3, but very upfield, and it's the B. So the order is C, A, D, and B. So it is a tentative proton NMR spectra analysis. Thank you. Because the splitting of protons, how they split and show the signal in a proton NMR spectra. If we talk about this methyl will show a triplet signal. How? Let's discuss. This methyl will split 3 times. 1 itself's proton. It has 2 protons, 1 and 2. First signal is of itself. The second signal is with this proton. Second signal of this proton. And the third signal is with the second proton of CH2, like this. प्रोटॉन NMR और स्प्लिटिंग से रिलेटेड मज़ीद वीडियोस देखने के लिए मेरा चैनल ज़रूर सब्सक्राइब करें. 3 signals. Okay, so the final spectra is like this: 1, 2, 3. Total of 3 signals. So it's a triplet. Okay.